Okay, Sherry, we have time for discussion. I think we have about 20 minutes for discussion. You had wanted to touch base again on the ESA-NASA astronaut training collaboration. One of the other questions that had popped up has been answered also in the chat. Let me address maybe the ESA NASA astronaut question first, and then we can go back to the chat window. And so I invite everybody, if you do have a question for any of the speakers, please indicate that with a Q and the speaker's name so that we can direct the question appropriately. But this is for all of the speakers today, including our lightning speakers. Okay, let's not forget them. Okay, so to restate what I said in the chat box, Sherry, is that I have personally spoken with some of the ESA trainers and some of the ESA astronauts, and they're interested in collaborative training activities, but that type of thing has not yet been approved at the agency level, which is where the decision has to be made. So I think that everybody is on board and interested in making those types of collaborative studies possible, but they've not occurred in the past. And I should explain that there historically has been a joint training between NASA, the Canadian Space Agency, CSA, and the Japanese Space Agency, JAXA, for many years. And so I've had CSA and JAXA astronauts in our classes at Meteor Crater in the Flagstaff area and in the classrooms here in Houston. But ESA has had thus far an independent training activity.
Thanks for answering that question again. So I have another question that maybe can be addressed by several people. So many of our earlier talks talked about the history of preparing for Apollo in different sites that the astronauts trained at. And so based on those sites and maybe some others, David and Noah and maybe others who are here, are there preferences for maybe certain sites that you think are more applicable to where we're planning to go at the lunar South Pole? Or are there new sites that you would like to explore as analogs for astronaut training?
Sherry, let me start, but we definitely should hear from Noah and Oz, and for that matter, anybody can chime in here. But I would say that we want to be conscious of the fact that the Artemis Exploration Zone, again, is an impact crater terrain. And so there has to be some emphasis on doing training in impact analog terrains or impact crater terrain. And so Meteor Crater, Schooner Crater, Sierra Madera, Reese Crater, Sudbury are all logical places. They're places that Apollo used, and they're places that we should, again, use. That said, you want to augment that strategically with other sites that introduce crew to other geologic processes or lithologies. And so the South Polar region is also a feldspathic highlands type of region. And so we should be training at the Stillwater complex or the Duluth complex or someplace like Mistoston, as Oz described, where anorthosites and anorthositic igneous assemblages are prevalent. And throughout that process, we have to train not only crew, but we have to train the science ops personnel and management. Everybody needs to get a better handle on field geology and field geological principles. In Apollo, everybody involved were either meteoriticists who understood extraterrestrial samples or were truly bona fide field geologists. Today, planetary sciences has very few bona fide field geologists. So we need to train everybody.
Oz, do you have anything to add?
Yeah, happy to. slightly biased because I'm up here in Canada, but and I can share, I was trying to dig out a link to an abstract actually presented at the recent USGS Analogs workshop that Noah alluded to too. But yeah, you know, there's the bottom line is there's no one single either impact or volcanic analog site that will, you know, do the job. I think, you know, as a scaled approach, Meteor Crater is a fantastic, you know, first crater for astronauts to see because, it's, you know, it's right there in your face and the geology is impressive. But there's a series of sites that appear in Canada that are, you know, are definitely a lot more accessible than they were during Apollo. You know, Sudbury's is a good example that was visited during the final 2 Apollo missions. Differentiated impact melt sheet, one of the biggest well-preserved craters we have here on Earth. You know, Mistastin is a site we're looking at. I presented on that. And there's also West Clearwater Lake too, up in northern Quebec, where you have, you know, cliffs and outcrops of impact melt, varied breccias, very complicated rock types that they'll be encountering in these South Polar terrains. And so I did put it in the chat, but, you know, I have been working with some of the trainers that I collaborated with during the ASCAN training, and we're looking at, you know, potentially Mistastin, Clearwater, other sites for training for Artemis. And yeah, you know, so I think there's a variety of sites up here.
Noah, do you have anything to add before we move on to some other questions?
I see Pascal has his hand up, so I might defer to him and think about what I'd like to add, but I'll let Pascal follow up, and then if I can go after Pascal, that would be fine.
Sounds great. Pascal, take it away.
Hello, everybody. This will be brief. I just agreed with everybody who just spoke about the need for a range of analogs that will cover the you know, the science diversity that we are wanting to explore on the moon. I just wanted to point out that we should also look at sites that combine that with operational constraints that are relevant as well. So one crater that has not been brought up yet is, of course, Houghton Crater, where I've worked quite a bit, and many others have as well. There you have not only, of course, an impact structure, but you have terrain that is essentially devoid of vegetation. Houghton is roughly the scale of Shackleton. It's 20 kilometers in diameter. Comms are horizontal because we need to talk to geostationary satellites once we're up there. And at that latitude, the comms run into ground effects, which will be essentially plaguing some of the surface comms issues that we have in the polar regions of the moon. And also there are things like 24 hours of daylight in the summer, etc. So, and incidentally, there are PSRs at Houghton, permanently shadowed regions, technically, where you do not see the disk of the sun. So they are places where we actually find some patches of permanent ice. Anyway, science analogs, but if possible, combining them with operational analogs as well would be great.
Thanks, Pascal. Noah, do you have some more to add on?
Yeah, I just wanted to follow on. You know, we're talking a lot about the geology, and that's good, but remember also the South Pole is going to be an incredibly challenging illumination environment. I turned off the lights in my office. You know, again, the sun is going to be coming in at effectively the horizon, as much as 7 degrees above the horizon in some places. It's going to be a challenge, and we have to train not only for the geology, but just the situational awareness of long shadows, of glaring sun and the opposition effect. And so we can simulate some of those things in the lab. And so I'd also push towards high polar environment, high terrestrial Arctic environments to, again, try to recreate just the sense. And maybe it's only during sunset or those wonderful times when the sun is around the horizon, but those moments where we can, again, try to synthesize, hey, this environment is going to be difficult from a lighting condition, from having, again, the sun straight in your eyes or long shadows, and simulating that aspect. And as has been said, you know, no one site will capture all that, but that has to be considered as well as recreating this in a natural environment, to go out, not just in a rock yard, but in a geologic environment. Hey, let's now go drill or seed some samples that we want crew to collect, because that challenge will also be present.
Thanks for all of those answers. And there's a related question while everyone's here. And we have a question that asks, does water saturation play a part in choosing exploration sites?
Maybe I need a follow-up question. Water, like detection of water at a location on the moon of where we're going to go. I guess if that's the case, certainly, that the remote sensing data for hydration for water at the surface of the moon, that's one of the reasons we want to go, is to find out what that water is and touch it. So absolutely, that's one of the criteria from a science standpoint that we have to bring to bear when picking sites. If I misinterpreted that question, or if there are other interpretations from this august panel, please correct me. But now,
great.
Saturation is a tricky question, because we know there's no saturated places on the moon. So if we find that, that'd be pretty cool.
All right. Well, we'll see if there's a follow-up to that later on. Maybe we'll kind of change subjects really quick. We have a question for Gregory Smith from Krista, and she says, great talk. You see the effects of simulant exposure on microglia, but do you know if there are cognitive effects of exposure to the simulant as well? So Gregory, can you address that question? Hopefully we still have Gregory with us. Not quite sure.
Well, since he's not speaking up, Sherry, maybe I can ask you and Zach a question. When you were doing the test, and I realized when your team has been doing the tests at Kilburn Hole, so let me bring everybody in. Did anybody do a test of comparing the geology that could be done without the instruments versus the geology that was done with the instruments? And that is assess the pros and cons of the additional load of instruments, kind of like Oz did with one of his exercises.
That's a great question, David. I know myself, and I believe Zach too, we're not involved in the RISE 4 expedition to Kilburn Hole. So we're newbies to this and have a lot to learn from our team members. But based on what I've learned, a lot of what was done in the field was kind of either compared to, at least the science was compared to what we could learn back in the lab, which was really interesting, comparing the field data to the lab data. But I'm not quite sure about, exploring what was done with and without the instruments. Zach, do you have anything to add to that?
Well, no, like you said, I haven't actually been a part of the RISE 2 deployments yet, thanks to the pandemic, but Bridging the Gap was slightly part of some of the work Oz was doing up in Western Ontario. So we've done a bit of field work with, well, especially with analog rovers, where you're comparing what humans can do versus just a full platform of or suite of instruments. And there's different strategies to mitigate it. I think one of the things we said along with those analog deployments was sort of like a walk around or a scan of the terrain. So when you put a human in the field, you do your basic observational work where you walk around, you take your brief field notes before diving into or identifying sites of interest that you then do additional data collection with handheld instruments. And I think that method is useful for sort of combining the without instruments, old school geology observation with all the new techniques we have.
Ben, maybe you can answer some of these questions too.
Sure, I was there. I'm probably the least qualified of all the people who were there to answer the question, but I could tell you how it worked. We did simulated EVAs and we did simulation of having essentially magical geological instruments, in that crew would mark a location that was of interest on the EVA, and it would take them no time on the clock of the EVA to get the reading, because a handler would sort of run over with a handheld instrument and actually hold it there after the crew had moved on. So we did not do any testing of the pros and cons of, say, having to hold a LIBS on a rock for a minute during an EVA, which would be an eternity. It was more about what was, and we wouldn't get the data from the LIBS during the EVA. This was all post EVA analysis of just trying to understand what you get afterwards and what kind of picture does that paint of where you've been.
Okay, thank you. Sherry, we have another 5 minutes. If you want to revisit the question about water saturation.
Sure. So it looks like we have a follow-up, and it says, from previous talks I've been in, there was mention of the possibility of water saturation linked with solar winds and eclipses. So I was interested in seeing if that is part of selecting the training sites.
So Noah, please go ahead.
Thanks, David. No, let me walk this backwards. So, we see hydration on the moon. If those are places that we end up wanting to go, which of course we will want to go to places we see water, then it comes down to how do we find an appropriate analog for that on the Earth? And again, appropriate. It's not going to capture all of the things. Now, very unlikely will we have crew, putting in a hand-pumped well to get that water out. It's more of working with the regolith, working with the materials. That we know we can simulate. And so it takes that question of, there's a science target that has a feature, a hydration feature, and say, okay, how do we get to a place on the Earth that gives us the best opportunity for astronauts to understand what it's like as best we can simulate in that environment on the Earth. And so we don't have to recreate the water on the moon on the Earth. We have to recreate the environment, working with the equipment, drilling in or putting in a drill, excuse me. And so I think it's an important distinction between finding an analog that tells you this is exactly what the moon is like. We won't have that, but this is the approximation of it that will give an astronaut and the folks working with astronauts, whether it's science background support, Capcoms, everyone else in mission control, an opportunity to say, these are the challenges that we'll have working in that environment. What happens when a drill bit gets stuck? What happens when the regolith is more compacted than we want? I'm going to now let you clean up my mess here, David, but I think that's the essence of what you're getting at, is finding the place that represents the environment and the type of thing, not necessarily going out and drilling into water, because we're not going to have water on the moon. We're going to have a special sample that we'll want to collect. How do we recreate that on the Earth?
Yeah, no, I would say that is a perfect answer. What I'd only do is expand upon that, is maybe better explain the sources of the origin, given the nature of this question. So let me just stipulate that over geologic time, volatiles to the lunar polar regions were delivered by impact cratering events, by volcanism, by solar wind, leaking from the crust. All of those are mechanisms that delivered volatiles, we think, to the polar regions. So, and one of the end games here is to locate sites where we can recover those resources for a sustainable lunar program. And that will involve not only studying sites where the volatiles may be most abundant, but studying sites where the nature of the volatiles, their distribution and their compositions may differ, so that we can better understand the transport and depositional processes, which will give us a much better global ISRU perspective. So that's kind of the backdrop. And what you said about analog training sites is exactly right.
Great, thank you both. And I think our question asker is very satisfied with that, and thanks you for your answers and clarification. David, I didn't see any more questions in the chat. Did I miss any that you picked up?
Well, Jacob Richardson has made a comment that people may want to pay attention to. And I think Ben Feist's hand may be up again. So maybe Ben has something more to say?
No, sorry, I just left it up because I'm not good at this.
Okay. Well, Sherry, I think that our time is just about over.
I think it is too. I want to thank everyone for being here and for joining us in our session. I think it was great to see all the presentations. Please check out the posters. There's a variety of topics to be discussed, and they all looked and sounded very interesting to me. So be sure to visit that in GatherTown. And I think with that, it wraps up our session today. So thank you to all of our speakers.